All right, today we're going to talk about graphing log functions. And we're going to focus the same as we did on part 1 of 7.2. We're going to really focus on the fact that exponentials and logs are inverses. And we're going to use our graph of an exponential, which we already know, and basically convert it into a log. So one thing we know about inverses in general is that what inverses really do is they switch the input and output. They switch x and y. So we're going to take everything that we learned about exponential graphs in 7.1. We're going to switch x and y, we're going to do it, and we're going to have a log graph. Now when I say switch x and y, it could be done to an actual equation. Like if I have y equals 2 to the x, I could switch the x and y and have x equals 2 to the y. You could also just do it to something as simple as a point. Like if the point 2, 5 is on the graph of an exponential, then you switch the 2 and the 5, you get 5, 2. That would be the point on the log. And it can even be done to something like an asymptote. So for example, if one of our graphs has an asymptote at x equals 0, the other one will have a graph at y equals 0. Or another way to think of it is axes. If one of them has an asymptote on the x-axis, the other will on the y-axis. So basically anything that has to do with one graph, if you switch x and y, will be true about the other. So I'm going to do a graph of each side by side. On the left, we have the exponential graph, which we've already done. And on the right, we have our log graph, which is new. And we'll go one step at a time, and we'll take each piece of the exponential graph, switch x and y, and it'll turn into a log graph. So one thing we know from 7.1 is that every exponential graph has a horizontal asymptote at y equals 0, or what we call the x-axis. That means every log graph has a vertical asymptote at x equals 0, or basically the y-axis. So see how switching x and y turned a horizontal asymptote into a vertical asymptote. Okay, then we have our key points. So for our exponential graph, we said every exponential graph has the point 0, 1. Well, if you switch the x and the y, instead of 0, 1, you have 1, 0. And that means every log graph has a point right there. Now for our exponential graph, the second point was 1, b. So let's do this. Let me get a little bit more specific here. Let's say our exponential graph is 3 to the x, and our log graph is log base 3 of x, just so we have a number to use. And as long as you use the same number, 3 and 3, as long as you use the same base, then they're going to be inverses. So for my exponential graph, I would go to the point 1, 3, over 1 up 3. That means for my log graph, instead of 1, 3, I would get 3, 1. So I'm going to go over 3 and up 1. So you guys can see I've done the exact same 3 things for log base 3 of x that I would for 3 to the x, except I just switched x and y on each one. Now when you go to draw the graph for both of them, you start at the asymptote and you have that kind of smooth curve shape going through those 2 points. Now the exponential graph, because it's a horizontal asymptote, starts on the left and curves through like this. The log graph, since you have a vertical asymptote, starts at the bottom and curves like that. But you can see we're doing the exact same 3 steps. It's asymptote, key points, draw the graph. We just switch x and y for a log graph. So log graphs are no harder than exponentials. They're the exact same graph actually. You just have to switch x and y. So even though we've kind of already done this, we just did log base 3 of x. And there's our key points. It's 1, 0 and b, 1 instead of, just switch x and y. So we'll do one more quick example, a nice easy one. So if we're going to graph log base 5 of x, we say just like for an exponential, there are 2 things that are automatic, but they're the opposite. You have to remember the differences. If you accidentally draw a horizontal asymptote for a log graph, the whole thing is wrong. So it's not a horizontal asymptote, it's a vertical. Every exponential graph has a horizontal asymptote. Every log graph has a vertical one. Then you go for your two key points. In 7.1, we did 0, 1. For a log graph, we do 1, 0. Then I look at the base and I see a 5 right there. And for an exponential, it would be over 1 up 5. For a log, it's over 5 up 1. You have your asymptote. You have your two key points. You start from the asymptote, curve through those two key points, and that's your log graph. So logs and exponentials are very, very similar. They are inverses, we know that, and as far as the work for graphing them, it's almost the exact same thing. Just make sure you really remember the differences. Like I mentioned earlier, if you get them mixed up and you do like an exponential thing for a log graph, the whole thing is messed up. So make sure you remember the key difference is the asymptote. If you remember the asymptote, everything else kind of comes together. Every exponential graph, no matter what, horizontal asymptote. Every log graph, no matter what, vertical asymptote. As long as you remember that, the rest of it is usually pretty easy to do. All right, so just like in 7.1, that brings us to transformations. And we're going to use the same transformations that we did in 7.1. In fact, I just put on here, H, K, A. Exact same as 7.1, exact same as 1.4 too, the first time we did them way back in chapter 1. So I'm not going to repeat notes. You guys have seen those, the videos on YouTube if you want to rewatch that one. But basically, you know, this K right here, that's a shift up and down. This H right here, that's a shift left and right. This X minus H here, if that's negative, it's a reflection. This A here is a stretch. If it's negative, it's a different reflection. You know, all those same transformations we've talked about like 3 or 4 times this year. Now the one key difference, remember with 7.1, when we did an exponential graph, we said the only transformation that will ever move the asymptote is a shift up or down. Now the reason for that is with an exponential graph, you have a horizontal asymptote. So imagine a line like this. If I take a horizontal asymptote and I shift it left or right, it's still the same line. But if I shift it up or down, it moves. Well, now we have a vertical asymptote, so the opposite is true. If I have a vertical line and I shift it up or down, it's the same line. But if I shift it left or right, it moves. So what you want to remember is it's the horizontal shift this time. It's H that would move the asymptote. Other than that, it's our same transformations. So let's go ahead and do a couple examples. We're going to graph f of x equals 3 times log base 5 of x minus 2 minus 1. And even though I didn't really ask you to, I'm going to make that list like I always do. I think it's good for the notes, and it's good for you guys to get used to, you know, normally you might do this mentally, but you want to make a list of your steps. So I will start. I notice it's a log graph, and I notice the base is 5. So I'm going to start with just y equals log base 5 of x. Actually, the exact same graph we did earlier. Then let's go through our transformations. So I'll look at this 3 right here, and I'll say that's a stretch. So I'm going to stretch this by a factor of 3. I have no reflections on here. If that was a negative 3, it would be a reflection. If the x minus 2 in parentheses had a negative in front of it, it could be a reflection. I have no reflections here, so I'm going to jump straight to the shifts. And I'm going to shift down 1 for that negative 1 right here. And I'm going to shift right 2 for that minus 2 right there. And then I'm going to remember when I shift it 2 spots to the right at the very end, that's going to be my last step, but that's going to take the asymptote with it because that shift to the right or the left moves the asymptote. So I have a plan now. I've kind of mentally, or not even mentally, I wrote out my steps. I have a plan for what I'm going to do. Let's do it. So I'm going to start with the graph of log base 5 of x, which, like I said, we actually just did. So that had a vertical asymptote, like every log graph. It had a point at 1, 0, like every log graph. And since the base is 5, I go over 5 and up 1. And that's my second key point for this graph. So here is our graph. Okay, log base 5 of x, same thing we had already done. Now let's stretch it vertically by a factor of 3. Now when you're stretching away from the x-axis. I'm going to focus on my key points again. And that first one, since it's on the x-axis, doesn't move. So this point is actually going to stay part of the graph. Remember, I said when you're stretching, you're multiplying the height by that number. And if the height is already 0, 0 times 3 is still 0. Now the other point, 5, 1, is going to be 5, 3. You're going to multiply, instead of being up 1, it's up 3 times 1, which is 3. So you get the point 5, 3 there. So what you get is it's going to start basically in the same place, but you get a slower, more gradual curve. Instead of that really sharp turn, it's kind of a smoother, slower curve. Now, final answer. We're going to shift everything down 1 and right 2. And what I'm going to do before I do anything is I'm going to do the asymptote. I know that the asymptote is going to move 2 spots to the right with my graph. So I'm going to put my new asymptote right here at positive 2. Then focus on the 2 key points from the green one. You're always working from your most recent one. And go 2 to the right and down 1. So the first point, 2 to the right, down 1, would end up being here, 3, -1. And the second point, 2 to the right and down 1, would be here at 7, 2. So for your final answer, start from the new asymptote, the purple one, and curve straight through those 2 points, just like that. So purple one is your final answer. We did a log graph, which we know how to do, just like exponential, but switch x and y. And then we did our same transformations. It's all some combination of shifting, stretching, reflecting. The other thing is, I mentioned it way back in chapter 1, you can do the transformations in any order, but I definitely suggest you do the shifting last, because shifting moves the asymptote and moves like the centering of the graph, and the stretching and the reflecting are harder if you've already moved it. So I would do all stretching and reflecting first and shifting last. Okay, let's do this one here. G of x equals 3 minus natural log of x plus 4. All right, so let's make a list again. Now what I noticed, this is a ln, or natural log graph. So I'm going to start with that. And what I'm going to do is I'm going to make a little note here. Natural log is base e, and e is about 2.7. Just like when we did e to the x, natural log x is about 2.7. Okay, now, I do have a reflection here. We have 3 minus natural log of x plus 4. That's like having 3 plus -1 times natural log. So that negative right there is going to be a reflection. So we're going to take our graph and we're going to reflect it. When the function itself, the exponential or log function, becomes negative, that's the vertical reflection. So it's going to flip everything from top to bottom. So I'll say reflect, we'll just put vertically. I talked about in 7.1, there's different ways to word it. You can say reflect up and down, reflect across the x-axis, reflect vertically, whatever makes sense to you, as long as you understand the concept. Now, what we have here, now I put the 3 in front, which is kind of makes it a little tricky. You look at that, some people might look at that and think it's a stretch because it's in front. It's not about where the number is, it's about what it's doing. So another way to write this equation would be g of x equals negative natural log of x plus 4 plus 3. I just took that positive 3 and I moved it to the end of the equation. If you write it like that, it's a little easier to see what you're actually doing. And now we're ready to shift. There's no stretch here. It's not like negative 2 natural log or negative 10 natural log of something. And there's no other reflection. The x plus 4 isn't negative. So we are ready to shift. And it's going to be up 3 for the positive 3 and left 4 for the x plus 4. And the left 4 will move the asymptote also. So let's start with natural log x, because we haven't graphed that yet. Just like any log graph, remember a natural log is still a log, so it has those same two things. It has a vertical asymptote at 0 and a point at 1, 0. Now the second point is always b, 1, and b is e, which is about 2.7. So for my second point, I'm going to approximate. I'm going to go over about 2.7 and up 1 and put a point right there. So that's what you do for natural log x, same as e to the x, just approximate e to be about 2.7. Then from your asymptote, draw your log graph. So that's natural log x. First of all, we hadn't done that together yet, just so you've seen it. Again, I'll tell you the same thing I did in 7.1. Don't be scared of natural log x. Just like I said, don't be scared of e to the x. It's not any harder than any other log graph. It's just a number. It's about 2.7. Okay, now, second step, we're going to reflect it vertically. So I'm using the x-axis as a mirror, which means this point will stay there. It's on the mirror. So all I have to do is take our second key point and instead of up 1, make it down 1. So make this point right here. And then when you're drawing your graph, instead of starting at the bottom, you start at the top. And you curve right through those 2 points. And that's a good vertical reflection right there, just by focusing on the asymptote and the 2 key points. Final answer is the shift. We're going to move everything up 3 and left 4. So let's start with the asymptote. If I shift the asymptote 4, it's going to be over here at negative 4. Now, from the green one, always your most recent one, take each of your key points, go up 3 and left 4. So the first one's easy. Up 3, left 4 would be right here. Be negative 3, 3. The other one, because remember you're starting at 2.7, you have to kind of approximate, so basically just count squares. The up 3 part is easy, but then when you're going over 4 squares, it's going to be 1, 2, 3, 4. It'll be about there. Once you have your asymptote and your 2 key points, you can always draw the graph. So we're starting at the top, just like we did with the green one, and we're curving through those 2 like that. So purple one is your final answer. It's a log graph, a natural log graph that's been reflected and then shifted. And again, we're just kind of practicing transformations with our new graphs. All right, let me go over a couple things with you real quick and then we'll be all done for today. There's a couple extra questions you're going to be asked in the homework today. So number 1, you're going to be asked about domain. Like, what is the domain of each function? Now, first of all, the reason this question didn't come up in 7.1 is the domain of every exponential graph is always all real numbers. So that's why I didn't even ask you. If you think about what an exponential graph looks like, x can be anything because it goes forever this way, it goes forever that way. You put any number in for x, it's going to work. Now, a log graph, that's not true for. So for a log graph, let's say we have one kind of like our last graph that looked like this. See, it doesn't exist everywhere. It goes forever in one direction, but it stops right when it hits that asymptote. It never gets smaller than that. So I said for a log graph, your domain is always going to be everything less than or greater than the asymptote. And the reason I said, like right here, you're seeing greater than. In fact, since the asymptote was -4 in our last example, the domain would be x is greater than -4. But if you had that other reflection in your graph, if your graph ended up looking like this, then your domain could be everything less than -4. But the domain for a log graph is always based on the asymptote. Once you find that asymptote, the function exists on one side of it. Greater than is to the right, less than is to the left. So you will be asked about domain in your questions today. Very simple, just basically greater than or less than the asymptote. The other thing you'll be asked to find is intercepts. So as a quick review, you always find an intercept by setting the other thing equal to 0. So like if I ask you to find the x-intercepts, and this is not just for log graphs, this is period, for any graph. So for any graph ever, if I ask you to find the x-intercepts, what I'm really doing is asking where y equals 0. So you set y equal to 0, and you solve for x. If I asked you to find the y-intercept, you set x equals 0 and solve for y. So that's basically what it mathematically or algebraically from an equation, that's what an intercept is. An intercept is you telling me what each variable equals when the other one is 0. So that's what you're going to be doing today. You're going to be doing graphs with transformations, and you are going to be asked those extra couple questions, things like domain and intercepts. But you guys have everything you know. Just remember, you have everything you need. Just remember that a log graph is basically an exponential where you switch x and y.